Okay, wrapping up chapter 8 for us today is 8.3, rational functions. The last section, 8.2, we focused on multiplication and division. This section is adding and subtracting. Who remembers what we have to have when we add and subtract fractions? In order to add and subtract fractions, you must have a common denominator. So just like with fractions of 1/4 plus 3/4, we had to have the common denominator to add 1 plus 3 all over 4. So we know in our mind that 1/4 of a pizza plus 3/4 of a pizza equals 1 whole pizza, or 4 over 4. So that should make sense to you that we do not add the denominators. So keep that in mind when we're dealing with rational functions. It's exactly the same. We must get a common denominator. So if we have two functions, x squared plus 5x, all divided by x squared minus 9, plus 6 over x squared minus 9, we have our common denominator. So we simply add the numerators and leave the common denominator. However, what's a little bit different now is we have to check for simplifying. We factor the numerator into x plus 2 times x plus 3. The denominator is the difference of two perfect squares, so that's x minus 3x plus 3. We have the same factors in the numerator and the denominator of x plus 3, so they cancel, leaving us our simplified answer of x plus 2 over x minus 3. So that helps us remind us to find the common denominator. That's nice when they give it to us, but not all of these are going to already have those given to us. You are going to have to find ways to get a common denominator. So let's look at these two rational expressions. These 5 over 6x plus 9 over 4x cubed, we notice that the denominators are no longer identical, but we must find out what would be a common denominator. If we look at 6x, we can break that down into 2 times 3 times x. You want prime numbers and the variables spread out as much as possible. So now 4x cubed is 2 times 2 times 3 times, 2 times 2 times x. And now we can start to find what is common. We know that we need at least one of these 2's and one of these x's, and those are in common, so we do not want to duplicate those. So we need 2 and an x for sure. These are already accounted for in both of these. Those not circled include a 3 and an 2 and an x and an x. So these we found and we did not want to duplicate. All of these still need to be included. So what is 2 times 3? 6 times 2 is 12. X times x times x is x cubed. So we know that we are looking at a common denominator of 12x cubed. Now, let's try to get those denominators to be in that format. So we know that we want the denominators to be 12x cubed when we're done. So we ask ourselves, we started with a 6x. What must we multiply 6x by to get to 12x cubed? We need to multiply 6 by 2 and x by x squared. If we multiply the denominator by 2x squared, we must multiply the numerator by 2x squared. So 5 times 2 times x is where this 10x squared comes from. So when you are looking at this 10x squared over 12x cubed, it is equivalent to 5 over 6x. we simply multiplied the numerator by 2x squared and the denominator by 2x squared. We'll do the same with the second fraction, 9 over 4x cubed. And we ask ourselves, what do we need to multiply 4x cubed by to get 12x cubed? We simply have to multiply it by 3. So then we multiply the numerator by 3. And that is where you get 27 over 12x cubed. Now we're adding these. When we add these, we only add the numerators. So we get 10x squared plus 27 all over our common denominator. So when we add two rational expressions that have different denominators, we first must find the common denominator and then simplify. So how do we add two functions? It's similar. They're fractions. So when we add two different functions, we are looking for our common denominators. So we are going to try to find a common denominator between 12x cubed minus 22x squared plus 6x and 30x squared minus 10x. Keep in mind, we still want to get things in a factored form so that we can see what would be a common factor. So when we factor 12x cubed minus 22x squared plus 6x, we can take out a common factor of 2x. Then we're left with 6x squared minus 11x plus 3. With the process of elimination, we know that the four factors are 2x, 3x minus 1, and 2x minus 3. Let's take a look now at 30x squared minus 10. Has a common factor of 10x, which means we have 3x minus 1. 10x can be rewritten as 10 times 5 times x times a quantity 3x minus 1. Now, what is common to both of them? We know that one thing in common is this 3x minus 1. And we know that there's a common 2. And we know that there's a common x. So those things, if we simply just multiplied the two polynomials together, those three things would be duplicated and make our denominator huge. So we would not be getting the smallest denominator possible. So we know if we take these three common factors and we don't forget the uncommon factors of 2x minus 3 and 5, now we take 2 times 5 times x times 3x minus 1 times 2x minus 3. That will be what we are going to work with. So let's take a look at our next slide. Our next slide is going to talk to us about how to find and combine those like terms and add the others. So we already mentioned that we needed to come up with a common denominator that will be 2 times 5 times x, or this 10x. We mentioned 3x minus 1 and 2x minus 3. That is the common denominator, and we just need to decide, well, what is missing? The first fraction we need to multiply by 5 in the denominator to get all of those factors to appear. Remember, if you multiply the denominator, you must multiply the numerator. So that 5 times 3 is where this 15 comes from. Now, the second fraction was missing the factor 2x minus 3. So in order to multiply the denominator by 2x minus 3, we must multiply the numerator by 2x minus 3. That gives us this x plus 1 and 2x minus 3. Remember, when we're adding, we only add the numerators. So we have 15 plus x plus 1, 2x minus 3. equals 10x times 3x minus 1 and 2x minus 3. You may not cancel these two. So make sure that you leave those alone. So the result is now in its lowest terms. Once you multiply out the numerator, add 15, combine like terms, but the denominator was already in its most simple form, so you can leave that alone. Remember, do not cancel this. This cannot be canceled because you have an addition sign here. So when it's all multiplication, you can cancel, but when there's addition or subtraction, you cannot. So once you find the sum and you get your function in its most simple form, of course we know how to evaluate. When it wants us to evaluate by 2, we substitute 2 in wherever there is an x. So what happens when we subtract rational expressions? Well, just like adding, you get a common denominator, but instead you now subtract the numerators. So we are going to find the common denominator and subtract the numerators. Let's find the common denominators here. Remember that when you have a variable that is like 2 minus y, you end up multiplying by a -1 so that you get the variable to have a positive coefficient. So that way we have y minus 2 and we have a -1 times y minus 2. This negative sign here is just like having a -1. So now what is common in the denominators? We have y minus 2 as the common denominator. So when we rewrite it with parentheses, we have y over y minus 2 minus, meaning subtraction, and then this original -3 over y minus 2. Remember, when we have 2, a subtract a negative, it becomes an addition problem. So we end up with y plus 3 over y minus 2. Do not add or subtract denominators, only numerators. So it's important to be super careful with those negative signs and subtraction signs, so take your time and be careful. Remember, we can always do 3 things. We can subtract and add. So do what's in the parentheses first, and then add in the second step, keeping common denominators at all times. So always work in factored form until you're at the very end and want to simplify. Otherwise, you'll just be refactoring and refactoring all the time. So the first result is from subtracting the first 2 fractions. Then we add the third fraction, and when we get done, we start to simplify. X squared minus 1 can also be factored, so x minus 1 plus x plus 1. Now we can, because there's no addition, we can start to simplify common factors. And look at that, it crosses off beautifully. Remember, when we're crossing off, we're saying x plus 1 over x plus 1 becomes a 1, because anything over itself is a 1. So when you get done, you have 1 times 1 in the numerator, which is why you have a 1 here. You have 1 times x in the denominator, which is why you have an x here. So 1 over x, that whole big blob simplifies to 1 over x. That's amazing. Be careful, write neatly, write big, and keep in mind that addition and subtraction require you to have common denominators. So this is just asking you to subtract these 2 functions. So subtract these 2 fractions, finding a common denominator. The common denominator is going to be x plus 1 times x minus 1. So each one of the individual fractions will be multiplied by x plus 1, and the other fraction will be multiplied by x minus 1. When you do that, you end up with this at the bottom, x minus 1 times x minus 1. Subtract x plus 1, x plus 1. Now, Again, you have to be very careful here. You cannot just start crossing off these two and these two. Because you have subtraction between them, you may not do that. You need to multiply these out. So you get x squared minus 2x, minus 2x plus 1. That is the first two brackets multiplied together. Now that stays in parentheses. You're going to subtract the next two multiplied together, and that is, you're going to have an x squared plus 1x or plus 2x. 1 times 1 is 1. Hopefully my mouse screen catches up to us. It's having a little trouble not making it very nice. Okay, so we are going to advance to the next screen to take a look at this. So you are going to see, sorry, it's not wanting to advance. Okay, finally, you can see in this step right here is where we were. You have x squared minus 2x plus 1. And then you're going to subtract everything in this parenthesis here. That means you change every sign. So you have a positive x squared becomes a negative x squared, a positive 2x becomes a negative 2x, and a positive 1 becomes a negative 1. Now you can combine like terms. X squared minus x squared, they're gone. Negative 2x and negative 2x is a negative 4x. 1 and a negative 1 are 0, so they're gone. So we end up with a result in the lowest terms. And that is how you subtract rational functions. So you can always verify using your graphing calculator to make sure that the values are the same across both functions. And remember, whether you're adding or subtracting functions, when you want to evaluate them, you simply substitute the number in for x and find your numeric answer. Have fun working in 8.3, and hopefully you remember all the tricks of adding and subtracting fractions of regular numbers, and that will help you with adding and subtracting rational functions. I hope everybody has a great day, and I'll talk to you real soon. Bye-bye.